In this first question, we are asked to just multiply these two expressions. So let's see how to do that. So since we are multiplying two fractions, all you need to do is multiply the numerator with numerator and denominator with denominator. Now, in the denominator, you have something of the form a minus b times a plus b. Now, that is nothing but a squared minus b squared, which is the same as 1 minus sine squared theta. Now, remember this identity. The identity is sine squared theta plus cosine squared theta is always 1, right? Which means cosine squared theta is 1 minus sine squared theta, right? So if you subtract sine squared theta from both sides, this is what you will get. Which means this can be rewritten like so. Your denominator can be replaced with cosine squared theta. So then what happens is this cosine theta gets cancelled with one of the cosine theta, giving you the final answer as 1 plus sine theta over cosine theta. That's your final answer. Okay. Okay, so this is the same thing. So let's do the same thing here. So this is my numerator. Why don't you pause here and try to do this on your own and then come back and check your answer with mine. Pretty much the same steps as what happened last time. Okay, that's your final answer. Okay, so here you're asked to add two fractions. Okay, so as you can see, both of these fractions do not have a common denominator. So you have to multiply both the denominators to make it a common denominator. So what happens is, I'm not going to rewrite this because it's taking up a lot of room. So I'm just going to do this in here. So in the next step, what will happen is your common denominator. So basically what you're trying to do here is you're multiplying the first fraction by sine over sine, and you're multiplying the second fraction by cosine over cosine. So in effect, you're multiplying both of them by 1, but this will make sure that your denominators match up. So then this is going to become sine theta times sine theta plus cosine theta plus cosine theta times cosine theta minus sine theta all over sine theta cosine theta. So let's distribute and combine like terms. So when you distribute here, what are you going to get? Sine squared theta plus sine theta cosine theta plus cosine squared theta minus cosine theta sine theta. So now this and this gets cancelled, and you know that sine squared theta plus cosine squared theta is just 1. So your final answer is this. Okay, can just leave it like that. Multiply and simplify. All right, so we are going to distribute the numerator, right? So sine theta plus cosine theta, times sine theta plus cosine theta will be sine squared theta plus 2 sine theta cosine theta plus cosine squared theta minus 1 all over sine theta cosine theta. So how did I get this? This whole thing was nothing but this. When you distribute this, this is what you will get. Okay, so you can do this on your own, however you do it. Combine the like terms, and this is what it will end up being. And then we are going to use this identity that sine squared plus cosine squared is equal to 1. Okay, so remember that. So what is the identity? Sine squared theta plus cosine squared theta is 1. Now, when you use that, what will happen is you have 1 plus 2 sine theta cosine theta minus the 1 from the numerator all over this. So here the 1 and the 1 gets cancelled away, right? Giving you this. Now I can cancel the sine theta with sine theta, cosine theta with the cosine theta, leaving me with 2 as my final answer. Okay. Factor and simplify. So remember, cosine squared theta minus 1 is nothing but of the form. So suppose say you had x squared minus 1. How will you factor it? It's x minus 1 times x plus 1, right? Similarly, cosine squared theta minus 1 will be cosine theta minus 1 times cosine theta plus 1. Okay. So your numerator is now going to become cosine theta minus 1 times cosine theta plus 1. In the denominator, cosine theta is the common factor. So when you take it out, this is what you will have. Then when you simplify this and this goes away, giving you your final answer as cosine theta plus 1 all over cosine theta. I can rewrite this again as 1 plus secant theta, but I'm just going to leave it like this for now. Okay, this is good enough. Okay, establish the identity. So when you're establishing the identity, you just pick one side that you want to work on, either the left or the right side. I'm going to use the left hand side. So I'm just going to write that expression. So I'm not going to write both, okay? So I'm going to write only one side, whichever side I want to work on, and I'm going to simplify that side and make it show that it is equal to the other side, okay? So I rewrite tangent as sine over cosine and cotangent as cosine over sine. Then I distribute, okay? So when you distribute, what happens? Your first one becomes cosine theta times sine theta over cosine theta plus cosine theta times cosine theta over sine theta. Now here the cosine and the cosine gets cancelled away. So this is going to become equal to sine theta plus cosine squared theta over sine theta. All right. So this sine theta, you can assume that there is a 1 underneath it. Okay. So now I am going to rewrite it as one single fraction. In order to do that, I need to multiply this by sine theta over sine theta, right? So then what happens is I'm going to take it here, sorry. So this is going to become sine squared theta over sine theta plus cosine squared theta over sine theta. So now you have got it into the same denominator. So keep the same denominator, combine the numerator. You already know sine squared plus cosine squared is 1. So this is 1 over sine. 1 over sine is nothing but cosecant, which was the right hand side that we had to prove. Okay, so we started with the left hand side. We kept on simplifying it till we were able to show that that expression simplified to the expression that was already on the right-hand side. So the same way, I'm going to start with the left-hand side here, and I'm going to keep working. So sine theta plus cosine theta the whole squared, when I expand it, I will get sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. So here I'm just using the identity that a plus b the whole squared is a squared plus 2ab plus b squared. So which means sine theta plus cosine theta the whole squared is sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. So this is the identity we are using. Now for the next one, the identity we will use is a minus b the whole squared is a squared minus 2ab plus b squared. So then I'm going to use that and I'm going to expand this. So this will become sine squared theta plus cosine squared theta minus 2 sine theta cosine theta. So then we cancel the common factor, which is these two are getting cancelled. Then what do we actually end up with? We know that this sine squared theta plus cosine squared theta is 1. This sine squared theta plus cosine squared is equal to 1. So 1 plus 1 is equal to 2, which was the right-hand side. Okay. So again, establishing another identity, I'm going to start with the left-hand side. Secant over cosecant plus sine over cosine. All right, secant. What is secant? It's 1 over cosine. What is cosecant? It's 1 over sine. What is this one? I'll just leave it alone for now. Okay, so then I take it here. How do you, so suppose if you have 1 over a over 1 over b, what do? You keep the 1 over a and you flip the 1 over b as a b over 1. So this becomes b over a. So this expression will become sine theta over cosine theta plus sine theta over cosine theta. We know that sine over cosine is tangent, and when you add a tangent with another tangent, you get two tangent. So that is how you prove this identity. Okay. All right. So now we have to find the exact value of cosine 7 pi over 12. Now 7 pi over 12 is not a unit circle angle, so we have to use the sum or the difference formula. Okay. So 7 pi over 12. What is 7 over 12? 7 over 12 is nothing but 4 over 12 plus 3 over 12, right? 4 plus 3 is 7. Now, if you simplify 4 over 12, you get 1/3. If you simplify 3 over 12, you get 1/4. So 7 pi over 12 is nothing but pi over 3 plus pi over 4. So this can be written as cosine of pi over 3 plus pi over 4. What is the sum formula for cosine? So cosine of a plus b is cosine a cosine b plus sine a sine b, right? So the angle in the place of a is pi over 3. The angle in the place of b is pi over 4. Wait, this is plus, right? So that means this will become minus. Okay, I hope my formula is correct. Okay, so then this will become cosine A cosine B minus sine A sine B. Okay, what is cosine pi over 3? It's 1/2. Cosine pi over 4, root 2 over 2, sine pi over 3, root 3 over 2, sine pi over 4, root 2 over 2. Simplify root 2 over 4 minus root 6 over 4. Combine, you will have root 2 minus root 6 all over 4 as your final answer. Okay. Okay, again, pi over 12. Now, 1 over 12, right? So 1 is nothing but, you can think of it as 4 minus 3 is 1, right? And what is 4 over 12? It's pi over 3 minus pi over 4. So this can be rewritten as sine of pi over 3 minus pi over 4. The formula for the difference of sine, difference of angle for sine is sine A cosine B minus cosine A sine B. Okay, so the angle in the place of A was pi over 3. The angle in the place of B is pi over 4. So this becomes sine pi over 3 cosine pi over 4 minus cosine pi over 3 sine pi over 4. Sine pi over 3 is root 2. Cosine pi over 4 is root 2 over 2 minus 1 half times root 2 over 2. So this is root 6 over 4 minus root 2 over 4. And that gives you the final answer as this. Okay. Does this make sense? You're just applying the formula and using your unit circle values. All right. So 7 pi over 12. We have already established what 7 pi over 12 is. It is nothing but 4 over 12 plus 3 over 12. 4 over 12 is pi third and pi fourths. And the sum formula for tangent will be tan A plus tan B over 1 minus tan A tan B, right? So this one becomes tangent pi over 3 plus pi over 4. So this is tan pi over 3 plus tan pi over 4 all over 1 minus tan pi over 3 times tan pi over 4. Now what is tangent pi over 3 is root 3. Tangent pi over 4 is 1. 1 minus root 3 times 1. So you end up with root 3 plus 1 over 1 minus root 3 as your final answer. No need to simplify. Okay. Okay, so here you already have this expanded. So you don't know the value of sine pi over 12 or cosine 7 pi over 12, but you see the pattern. What you have here is something of the form sine A cosine B minus cosine A sine B. Now this is nothing but sine of A minus B. So what is the angle in the A position? Pi over 12. What is the angle in the B position? 7 pi over 12. Okay. Now, when you subtract this, what you get? You will get negative 6 pi over 12 because 1 minus 7 is negative 6. Okay. Now, sine is an odd function, which means sine of a negative angle is the same as negative sine of the positive angle. Okay. So this is equal to negative sine 6 pi over 12. Now, what is 6 pi over 12? It's nothing but 1 half, correct? So, this is negative sine pi over 2. We all know what sine pi over 2 is. It's 1. So, we have negative of 1, which is negative 1. Okay? Okay, so we have to find two things here, and these are the conditions given to you. So there are two angles involved, right? So we have to find these cosine and sine of the sum and difference of those two angles. The only thing that we know about these angles is that the first angle is in the quadrant 1. So alpha is in quadrant 1, correct? Because it is between 0 and pi over 2. Whereas the second angle is, if you look at the second angle, they're saying that it is here between negative pi over 2 to 0. So that is in quadrant 4. Okay. So the formula for cosine A plus B is cosine A cosine B minus sine A sine B. So this means that I need the value of cosine A cosine B and sine A sine B. I'm only given cosine A. I don't know what sine A is, but I can find that, right? Because what is sine? Sine is y over r. What is cosine? Cosine is x over r. So set up x squared plus y squared is r squared. Root 5 squared plus y squared is 5 squared. 5 plus y squared is 25. Y squared is 20. Y is square root of 20. I'm only using the positive value because I know that in quadrant 1, y is positive. So this gives me sine alpha is root 20 over 5. Okay, so just keep this with you. That's all you need to do for now. Now let's go here to this. I'm going to use the value given to me to find cosine B. So I know that sine B is y over r, cosine is x over r. So I set up x squared plus y squared is r squared. So solve this. You'll get x is either plus or minus 3. Now look at this fourth quadrant. What is x? X is positive. So I'm only going to use the positive value, not the negative value. Okay. So now I also have cosine B value as 3/5. Now that's it. These are the only two missing pieces because all we need are these four values. Okay. Okay, so now I'm taking this here to the next slide. I just copied it so that we will be able to proceed with this, okay? So I'm going to erase all of this because it's in the previous slide for you. All right, so let's look at the previous slide. What do we have? We have the values for cosine A, sine B, cosine B, okay? So I'm just going to rewrite it in this next slide. So what do we have? I'm just rewriting it. We have cosine A was given to us, and we found sine A to be root 20 over 5. Sine B was given to us, and we found cosine B to be 3/5. So now I write the formula for cosine A plus B as cosine A cosine B minus sine A sine B. I set it up. What is cosine A? Root 5 over 5. Cosine B, 3/5 minus sine A, root 20 over 5. Sine B, negative 4/5. So then what I have is 3 root 5 over 25 plus 4 root 20 over 25. Now what is root 20? Root 20 is root 4 times root 5. So that is 2 root 5. So we can rewrite this as 3 root 5 over 25 plus 4 times 2 root 5. So that becomes 8 root 5 over 25. So the final answer is 11 root 5 over 25. So 4 times 2 root 5 is 8 root 5. So that is the answer for cosine A plus B. Okay. So now in this next slide, I'm going to do the other one, which is sine A minus B. So you might want to pause and do this on your own. I will just write the formula for you. Sine A minus B is sine A cosine B minus cosine A sine B. You have all the values, okay? So we just rewrote this as 2 root 5 over 5 just for your information, okay? So now use these values to rewrite or to evaluate and then check back with me. This is what I got. All right. Okay. Takes us to the next question. Sine theta is 1/3, theta is in quadrant 2. Find this value. Okay. So we are going to use the difference formula for cosine. And the difference formula is nothing but cosine A cosine B plus sine A sine B. In the second quadrant, cosine is negative, right? So, second quadrant cosine is negative. So if sine theta is 1/3 and sine theta is y over r, x squared plus y squared is r squared. So we have x squared plus 1 squared is 3 squared. X squared plus 1 is 9. X squared is 8. X is plus or minus 2 root 2. But because it is the second quadrant, I only take the negative value. So which means cosine theta is negative 2 root 2 over 3. Okay, so this is the value that I am interested in. I hope this makes sense to you. So we are just using the x squared minus y squared equals r squared to evaluate cosine theta, given sine theta is 1/3. And that's it. Now we plug everything in. So cosine theta is negative 2 root 2 over 3. I know cosine pi over 3 is 1/2. It's a unit circle angle. Sine theta was given to be 1/3, and I know sine pi over 3 is root 3 over 2. So now I simplify. So this 2 and this 2 goes away. Okay. So then my answer is just negative root 2 over 3 plus root 3 over 6. That's it. Okay. Okay, to establish the identity, I start with the left-hand side. Sine 3 pi over 2 plus theta. Sine sum formula is sine A cosine B plus cosine A sine B. What is sine 3 pi over 2? Negative 1 times cosine theta. Cosine 3 pi over 2 is 0 sine theta. So that means this expression goes away. 0 multiplied with anything is 0. So this gives you negative cosine theta, which was the right hand side. Because negative 1 times cosine theta is just negative cosine theta. All right. Tan inverse of, so basically what I'm going to do here is the two of these, right? The inverse trig functions are angles. So I'm going to say let tan inverse of 4/3 be some angle A. And I also will let cosine inverse of 513 be some angle B, which means tan A is 4/3, cosine B is 513. Okay. Now this then becomes cosine of A plus B, right? Which is nothing but cosine A cosine B minus sine A sine B. So I need the value of cosine A cosine B sine A sine B. I have cosine B, correct? The rest I don't have. So what is the next value I need? I need sine B. Okay. So then if I use my Pythagorean identity that x squared plus y squared is r squared, knowing that sine is nothing but y over r, given x over r, I can solve for it. The x, so what is my x? X is 5, y is the unknown, right? If you solve for this, you will get y is either plus or minus 12. Okay. Now you know that if cosine has cosine inverse, right, like the value inside is positive, we know that the angle is in the first quadrant. So we are also going to use y as just positive 12. Okay. So then we get cosine B will be equal to 12 over 13. So see what we did here. What we did here was that we used the value of cosine B, right? And then we wrote the value of sine B using this formula. Sine B is nothing but y over r. So we are going to do the same thing here. We were given the tangent, correct? What is tangent? Tangent is y over x. So we have x squared plus y squared is r squared. So that means 3 squared plus 4 squared. When you solve it, you will get r is equal to 5. Once you get r is 5, you know that sine A will be 4 over 5, cosine A will be 3 over 5. Because sine is y over r, cosine is x over r. Okay, so now you have everything that you need. So let us do this. So let us take it here and then write everything down. So we have cosine A to be 3/5. We have sine A to be 4/5. We have cosine B to be, what is cosine B? 5 over 13. And we have sine B to be 12 over 13. So we got all of these values from the two angles that were given to us, right? The two inside angles. So now that we have all of this, all we need to do in the next step is plug everything in. Okay, so now I plug in. So I have cosine A plus B is cosine A cosine B minus sine A sine B. What is cosine A? 3/5. cosine B 5/13, sine A 4/5, sine B 12/13. So you have 15 over 65 minus 48 over 65, which is negative 33 over 65 is your final answer. Okay. Okay, same thing here. This is, so I'm going to say let the inner angle be equal to some angle B. Okay. So that means cosine B is 3/5. Okay. Which means sine B is 4/5 because 3, 4, 5 is an easy right triangle. And tan B is 4/3. So this becomes tan pi over 4 minus B, which is tan A minus tan B over 1 minus tan A tan B. What is tan pi over 4? 1. What is tan B? 4/3. 1 minus 1 times 4/3. So combine the terms here. 1 minus 4/3 is negative 1/3. Or you can just multiply throughout by 3. That will make your life easier. So then you will have 3 minus 4 over what? 3 minus 4 over 3 minus 4. So that's a 1. Is that right? Oh, this is a 1 plus. Okay, that's why. Okay, this is a 1 plus. So you'll have negative 1 over 7. I hope this is correct. It doesn't look correct to me, but I'm assuming it is. I don't think we made any mistake. Unless I got the formula wrong, but I don't think so. Okay. Okay, let's leave it at that. Okay, so the next one, find the exact value of all of these given these. So right now I'm just going to duplicate this slide because we know that we need more. So let's do this sine double angle. So sine double angle is nothing but 2 sine theta cosine theta. Okay. Cosine theta is given to you. What is sine theta? See, whenever you have 3/5 as a value, you know that the other value is 4/5. And this is quadrant 1. So I automatically know that sine theta is 4/5. I don't have to do too much calculation for a 3, 4, 5 right triangle. Okay. So then I substitute 2 times 4/5 times 3/5 is 24 over 25. Cosine 2 theta is nothing but cosine squared theta minus sine squared theta. What is cosine theta? 3/5. Sine squared theta 4/5 squared, which is 9 over 25 minus 16 over 25. That is negative 7 over 25. Okay. So now let's do sine theta over 2. So we have to use the half angle formula for this. So the half angle formula is, let me just derive it very quickly. So you know that cosine 2 theta is nothing but cosine squared minus sine squared, right? Which is, or it can be thought of as 1 minus 2 sine squared, right? Which means 2 sine squared is 1 minus cosine 2 theta. So that means sine theta over 2 will be plus or minus square root of 1 minus cosine theta over 2. Okay, so that's what it is. And because the angle is in the first quadrant, I'm just going to use the positive value. It is 1 minus cosine theta over 2. This is the formula. So I plug in, I have 1 minus 3/5 over 2. Now, what is 1 minus 3/5? It is 5 minus 3, 2/5, right? So this is 2/5 over 2, which is square root of 1 over 5. That is the value. Okay. So you can just leave it like that. Or you can rationalize the denominator and write it as root 5 over 5. Now cosine theta over 2 is square root of 1 plus cosine theta over 2. I'm just using the positive because these are all in the first quadrant. So you have 1 plus 3/5 over 2, which is 8/5 over 2, which is 4/5, which is 2 over root 5 or 2 root 5 over 5. So these are our final answers for the half angles. That brings us to the last question. So we are going to do the same thing in here, except that this angle is now in the third quadrant. Am I right? I'm sorry, fourth quadrant. Because this angle is between 3 pi over 2 and 2 pi. So quadrant 4. So in quadrant 4, sine is negative, whereas cosine is positive. Okay. So then you do x squared plus y squared is r squared. X squared plus negative root 3 squared is 3 squared. So x squared plus 3 is 9. X squared is 6. X is square root of 6. I'm just using the positive because it's the fourth quadrant. X is positive. Okay. So then I go back and write these because I know this already, right? So sine 2 theta is nothing but 2 sine theta cosine theta, right? Which is 2 times, what is my sine theta? Negative root 3 over 3. What is my cosine theta? Root 6 over 3. Okay. And then you multiply them all. So you will get negative 2 root 18 over 9. If you want, you can simplify this. Root 18 is nothing but 9 times 2, correct? So this will become negative 6 root 2, right, over 9, which can be simplified as negative 2 root 2 over 3 if you want, okay? You can do all of that simplification. All right, then cosine 2 theta, right? Cosine 2 theta is cosine squared minus sine squared. What is my cosine theta? Root 6 over 3. When you square it, you'll get 6 over 9 minus sine theta. When you square it, you'll get 3 over 9. So the answer will be 3 over 9 is cosine 2 theta. Okay, so now um, okay, so we found out cosine theta to be root 6 over 3. Remember that. So sine, so these are all for fourth quadrant, correct? So fourth quadrant, that means theta over 2 will be in the second quadrant. Sine is positive. So I'll just use the positive value and write 1 minus cosine theta over 2, which is 1 minus root 6 over 3 all over 2. Simplify it. I will get 3 minus root 6 over 6. and I'll just leave it like that. Okay. Now for cosine theta over 2, now this falls in the second quadrant, cosine is negative. So I have negative square root of 1 plus cosine theta over 2, which is negative square root of, so let me rewrite this. So if you're wondering how I'm simplifying these, I'm just doing this in my head, like I'm making 1 as 3 over 3, right? So then this will become 3 plus root 6, and this 3 denominator will go and combine with the 2 and become 6. So this is my final answer. Okay.